Um, Sorry, please, I have a question.
This meeting is being recorded.
Okay.
All right, please, I was not in the first session. I'm just joining today, so I don't know.
Okay. I would
Do I?
give it.
uh,
It's fine. Last week's session was an introductory phase into data and data analysis. So um, it's still very useful to have this second part. You would still find it very very useful. All right.
All right,
So
thank
let me just start off with a bit of a recap of what we had last week, the first part, for the benefit of those that were maybe not in that session. So we discussed about the concept of data. We defined what data is, and we also itemized the fact that data is like it forms the basic atom of decision making, and how intelligent decisions are usually backed or driven by data. We also give some instances of the applications of data and the different spaces, the different industries, and in the different ways that they use data analysis. Then we talked about different data types and forms. We talked about how data can exist in a myriad of forms, and then we now narrowed it down to focus on structured data versus unstructured data, for which, as a data analyst, you would find yourself working a lot with structured data. And maybe just for the benefit of others who were not around, structured data is usually your data that is organized into rows and columns. The type of data you find on your data in your database. You have Excel sheets, you have databases and other things like that. So basically, structured data is what we'll be narrowing down further in this second part to discuss how we use tools like Microsoft Excel, Power BI, and even programming Python to improve data analysis workflow and skills in general. So let's just kick off with today's session. Okay, so for today's program, I will basically be starting with what statistics is and the role that statistics plays in data analysis. Then I will talk about the application of statistics in data analysis and also the application of statistics in data analysis in the different work areas of life. So I'll talk about it from different work perspectives. Then I'll talk about something called the missing values problem. So usually as an analyst, you will not always have all the data that you have that you want to use to carry out your analysis. So I'll just touch on what you can do when you are faced with that situation. Then next, we'll talk about something called correlation versus causation. And then I would now deep dive into what we call context and how the context in which you are looking at data plays a major role in your overall analysis. Then I will now talk about skills, tools, and applications. And at this point, I'm going to do something interesting and we would break off, and I will basically be showing you a typical data analysis workflow. How we start from your data gathering phase to your data transformation, your data cleaning, because it's very important that you prepare your data, you transform your data before you then perform analysis on your data. So I would break off to show that practical workflow. You would agree with me that a 1 hour session might not be enough to maybe teach you all that you need to know about data analysis or to start you off. But the idea today is just to expose you to some key concepts that you would need as an up-and-coming data analyst. And then this case study will just show you the typical workflow of a data analyst in a company, an organization, or if you're just doing a private research. Then we'll come back from the case study break and then narrow in on hard skills that you need for data analysis and then soft skills before we now conclude today's session. So I hope you're all ready to go on this journey, with me. So first, like I said earlier, we're starting with statistics. Basically, Investopedia just defines statistics as a branch of applied mathematics that involves the collection, the description, the analysis, and inference and conclusions from quantitative data. If you recall last week, when we were talking about the different forms of data, I mentioned quantitative and qualitative data. And I talked about how quantitative data is something that you can measure, you can count. It's typically things you see that is occurring as numbers, digits, integers, and the likes. So statistics basically is that branch of mathematics that focuses on describing quantitative data. It looks at grouping quantitative data, it looks at analyzing and then drawing inferences and conclusions. From this definition, you quickly see that statistics is very, very much related to what we'll be doing as data analysts. And it will be very good that we appreciate the role of statistics in our work as data analysts. Next, I want to talk about how statistics is majorly categorized into two main types. One being descriptive statistics, and then the other one being inferential statistics. Descriptive statistics basically is just you're looking at data, and then you're summarizing what this entire group or population of data is telling you, and then you're presenting it as, say, maybe graphs, tables, and charts. So basically, you just have like a data set, and you're trying to make sense of what. Okay, let's admit some people in. Yes, so yeah, so we're trying to make sense of what the group of data is telling us, and we are just summarizing it. Next, we have inferential statistics. And inferential statistics basically just means you giving a meaning to your collected data and your projects. So you have your group of data, and then you're trying to draw out meanings from that group of data. So these are the two main kind of statistics that we have in the context of what statistics is. So next, I want to just touch on what the different applications of statistics is. So here we are saying that we have statistics has many applications in real life, and you agree with me. So for example, we can use statistics in accounting and audit. So for example, in audit, because I want to just give a perspective from my previous work experience. So as an auditor, there is something you'll be dealing with a group of transactions. So usually when you're assessing a group of transactions, you might be looking at as much as 5,000 transactions, and you're supposed to validate and test what those group of transactions are doing. You're supposed to test that maybe they actually happened and they are fair transactions. So usually, because you cannot just test everything, there is an approach in audit that is sort of called it's called like a targeted testing. So what you basically do with your data here is that you are ranking your transactions from the highest, your largest, to the smallest transaction. And so, for example, imagine you're running a shop and you have a group of transactions. You agree with me that one of the things that you really find as important is those large transactions, the big item transactions. So transactions that maybe consume a lot of money. So in audit, you rank those transactions based on their value, and then you now can get those high values and then test them. So as simple as this sounds, you're already applying the idea of statistics, grouping, and sampling to your analysis at that point in time. So another thing is, for example, you might also want to look at very small transactions that maybe when you add them together, they like mean a lot. So these are the different perspectives that you want to be assessing statistics in the context of your work. So that was just a perspective from the accounting and audit space. Another thing in, like, for example, in performance management, so let's say you are a human resource representative, and then you're supposed to come up with a sort of metric analysis that's tracking how well staff of the company is performing. So you would, as the analyst, you would have to discuss with stakeholders, and by discussing with stakeholders, you'll be able to establish the key metrics, the key metrics that you'll be measuring. And from these measured metrics, you can now start tracking the performance of people and maybe departments as a whole. Next thing is here, I want to give a bit of perspectives in software development and testing. So there is something called regression testing or regression analysis in software testing. And basically, this like after you've developed maybe a software or a page, you are now looking at, okay, I want to assess each component of this page, product or software, and I want to see if I change something in this software, what will it amount to in the overall software. So if I make a small thing in this section, will it affect the performance of the software or the product as a whole? So that form of regression testing involves you applying it's a statistical application in software development and testing. Then also in geographic information system and population planning, I think I remember I gave an example last week where we were talking about how we can group the different population sizes and then attribute characteristics to each group of population. So we start saying that you cannot really separate statistics from data analysis. As a data analyst, you will find yourself continually using or employing statistical tools, techniques, and methods in your workflow, in your workflow procedure. So next, I highlighted something here that said practically anything that is quantitative. When you want to analyze anything that's quantitative, you will definitely benefit from using statistics and statistical concepts. Next, I want to talk about something that's called the missing values problem. As an analyst, there are times that you will not always have all the data sets that you want. You will not always have all the data points that you need to make your analysis. So, for example, you are supposed to analyze sales records from, let's say, 1,000 branches, or let's say 500 to 1,000 branches. And then maybe as at the point in time when you are to perform the analysis, maybe there is a deadline or something of the likes, then you now see that at that point in time, you don't have all the sales transactions from all the 1,000 branches. You have from maybe 990 branches or maybe 999 branches. Would you say because you don't have data from one branch that you will not continue analysis? The answer is no. So it's a common thing that happens in the space of data analysis, and it's important to know how to deal with this missing values problem. So depending on the nature of your data, you may decide to exclude those sampling points from the analysis. So for this set of branches, I might just say, I want to exclude this particular branch from the analysis. So when I'm giving this analysis, I also want to note that, oh, this analysis excludes this branch from Lagos mainland or something like that, so that the users of your analysis or the users of your results will know that there are some limitations to the use of your analysis. So if you pay attention to what I've said, it means that as an analyst, you need to know how to be comfortable with incomplete data. Especially when you still need to perform that analysis. You cannot say maybe grant a project just because you don't have all of the data that you require to perform that analysis. Then another way to deal with this problem is something that's called mean value imputation. So if in the case of that missing singular branch, it might just make sense for you to calculate the mean of all the maybe sales transactions in the other branches and then substitute that missing value with that mean value. So you agree with me that you substituting it with the mean value does not necessarily mean that you are putting in the accurate value for that branch, but it gives an estimate of what could likely have come from that branch. So this is another very important or very useful way that analysts deal with missing data or missing value. Some people also maybe just substitute the missing values with maybe zero. Maybe they substitute it with another maybe value that they decide would make sense for that data set. So it is very important that while you are dealing with missing data, you need to assess the impact of the approach that you are deciding to go with on resolving that missing value. So you need to know the impact of what. So if I'm replacing it with mean values, what does it imply for my entire data set? If I'm excluding that sampling point from my analysis, what does it mean for the data analysis projects? So next, I want to talk about correlation and causation. So a common misconception amongst maybe beginners in the data analysis space is usually when you are assessing two variables or two occurrences. Let me not use too much technical term. Maybe you're looking at two values, and then maybe you've plotted a scatter plot for the two properties, and then you are seeing that as this property A is increasing, property B is also increasing. There is a tendency to think that maybe property A is causing property B, that maybe when property A definitely increases, then property B will always increase. It is a common misconception to think that that relationship exists when you just see any positive correlation between your data. So one key thing to take away from here is to know that correlation between different factors does not necessarily mean causation. It does not mean that they are maybe actually related. They may show a good degree of correlation, and their correlation coefficient, that's talking in terms of mathematical term, their correlation coefficient may be very high, maybe 90% or 95%. It does not necessarily mean that these two variables are necessarily dependent on themselves. It might just be a coincidence. So this is another thing that you need to take into consideration as an analyst. So here I just defined what correlation means. So correlation is just measuring the linear or direct statistical relationships between two random variables, and while causation indicates that one event is as a result of the other event. So based on this, it's good to note that, or one thing I just want us to take away from this particular slide is correlation is not causation. That you see a good relationship between two things does not mean that they are solidly related or that one factor is causing another. You need to do a secondary assessment to look at how actually related these two things or these multiple things are. Next, we have context, and context basically means we need to be able to look at our data in the correct sense that it is being presented. So So what I've said here is that while statistics may be a great way to present your data, the context that it is being presented is very important. So some data sets or some analysis means something in different contexts. And as an analyst, it's always important that you do not maybe take things out of context. If a data set is just talking about the population, then you should know that all of your inferences should be related to that population. You would not want to now project maybe that population to another unrelated population. That's one of the ways that you can look at context. So if you're looking at data from, let's say we analyzed results or scores from a group of farmers, maybe the amount of harvest yield or products that they got from their farm for the year, and then you saw that maybe they had good yield that was increasing towards the end of the year. The context in which that particular data be presented is agriculture and farmers in, say, Lagos State. It would not make sense to now say we want to now project that same analysis to, say, farmers in Sweden, because the environment is totally different in Sweden. The factors that affect agriculture and farming activities in Sweden is totally different from what is affecting agriculture and farming in Nigeria or Lagos. So you need to also put that in mind when you're analyzing data or when you're making inferences or suggestions from an analysis that you have performed. So like I said, your context is key. So next, I want to just touch on what we would say are the skills, tools, and applications, like what we said we'll be discussing in this part of the series. So one of the things I want to highlight here is that in the data spectrum, data space, we have like a whole lot of there are a whole lot of disciplines and sub-disciplines. Like here I listed the data analysts. There's also data engineers. We have data scientists. We have machine learning engineers. Data. There are just so many like that, and in fact, sometimes some of these roles they share some activities or some functions. They share some skills. They share some tools as well. But in general, and for the purpose of this class, one we need to I want to highlight that one we need to possess some particular skills in order to succeed in any of these rules. So next, I want to go over to the case study brief, where we'll be using some of these skills and tools, basically. So first of all, let me just mention some of those very important, maybe technical skills that you would need as an analyst. So probably need to be good with you need to be good with SQL as an analyst. That's SQL query language. Programming language too might also be very useful or for an analyst that wants to increase automation. So if you want to automate some of your processes, like maybe your data collection process, you want to automate it by maybe scraping or getting data from a dynamic page or a website, then you might need to now incorporate programming skills into your SQL skills. Let me mention SQL is basically a SQL query language for databases. So it's basically the language of databases. I explained last week what these databases are, and I think I detailed that basically in your databases, you just have a set of related records, tables, and fields that just bear relationships with one another. So your database just houses those different records and data sets. And then SQL is what you use to communicate with that database in order to pull out any, say, field or record that you need for your analysis. So next, let me just talk about this case study. So for example, so I noticed something. I was in a community where a number of scholars were discussing a recent interview, scholarship interview, and then people were basically speculating on, say, maybe the number of applicants and the number of successful awardees and the likes. So this case study will just take you through my thought process as to how the project was conceived, and then how we move from gathering the data to transforming the data that we collected, cleaning it up, and then how we did some small analysis and presented results. So in this example is just like a guide, just for you to appreciate the common workflow of an analyst. So please confirm that you can still see my screen.
We can see.
Okay, so this first part of the case study is making use of Python, so programming. So the problem here was that I needed to extract data from this website, this page, and then we saw that the data was housed on multiple tables in 922 pages. Now there are easier ways there are like easy ways to pull out data from websites in things like Power Query, where you just input the URL. I think I'll also show that later on. But when you are dealing with something as large as, say, 922 pages, then it's very important to bring in some form of automation. So that is where this whole idea of using Jupyter notebooks and Python to automate that data collection procedure. So what did we do? So I'll just talk through it. So in the notebook here, we imported a number of a library. And what would you say a library is? A library is basically a collection of modules. So it's a collection of code, but like bunches of code in Python that you can reuse. So in this first step, in the first line, you see that we imported pandas. Pandas is the library that was used for this analysis. Pandas is basically used for data manipulation and analysis. It helps you also structure data. So when you pull out data, you can put it into tables, that is rows and columns. That is, you can put it in structured data format, and then you can manipulate numerical tables and time series data. So next, request is another important like a key function. So we imported that as well, and request basically just helps you pull out information from HTML, HTTP sites. So request is what you use to get data from websites. You can use it to get data from websites. While Beautiful Soup was used to pull out this data from that website. So next we defined some when I say functions, and we defined a range. So basically, if you see here, the range was from 1 to 922. That is the number of pages that we want to pull out data from, and then we now fed in the URL into it, giving with the first page now ranging from this I that we defined from 1 to 922. So we are basically going to use the request function to pull out data from that website from page 1 to page 922. And then we are going to organize it into a table. And this process was run one time, 922 times for each pages, and then it was then organized into tables and rows before we now put it into a data frame that is in a structured So now we now have headers, rows and columns and the likes, and they exported it to a CSV file that was called this name here. So basically, a CSV file is just comma separated values. You can view it in Excel. If you open it, you just see like a table. So this process of automation saved us a ton of time. You can imagine what you are doing if you were maybe manually copying each page and then pasting it into maybe Excel or something like that. And then you see that something like Python can help you greatly accelerate your workflow as a data analyst. So next, I want to talk about something called Power Query in Power BI and Excel, because I mentioned that we'll be talking about how we can do data analysis in Excel and Power BI. So I'll just open Power BI here, and please confirm you can still see my screen.
Yeah, we can still see your screen, sir.
All right, that's great. So within Power BI, to perform an analysis, you need to bring in your data, transform it, and then you do your analysis on it. So usually you do that with the get data. That's basically how you import data. So let's see. We'll pick the data type. You can see that there are different data sources that you can connect to. And for this demonstration, I want to use text or CSV. And then it takes us to let me see. It takes us to a dialog box where you can select the data. Let me see. Let me make use of Excel instead. Okay. Let's see. I'm trying to let's get the sample data. Let's see. Okay. So you could specify the data type and then you load it. So the interface that comes out immediately is what we call Power Query. And Power Query is common to both Power BI and Excel. It's also used in other like Microsoft application or Power Platforms. So in your Power Query, you basically be able to view all of the table, all of the data that is contained within your within the data you're trying to import. So let me just show you how this is also possible in Excel. So for example, you want to bring in data, so you come to the data tab in your Excel, and then you get data, and then you also pick the file type. And then let me see, I want to work with CSV here. Yeah, so let's import that. So you see the same dialog box comes out for the same data. So what do I want to highlight here is that Power Query, you can use it in Excel. So you can do a lot of data transformation in Excel, or you can do it within Power BI. Yeah, so for this one, let's see. So you can now proceed to transform your data. So when you're transforming your data, this is the Power Query interface, basically. So you can see on this right side, there are applied steps. It shows you how Power source of the data. You did some automatic things like promoting data to headers, and when you do some, let's say, some study on your own, you understand what some of these things mean. And then you can also do things like changing data type. Where say for example, you want to change this sales price. I can see it's in dollar, but you want to say maybe you want to change it to maybe currency type or something like that. then you would, okay, you want to change it to, let's see. Okay, so it's in alphabet form, but let's say you want to change the data type, then you can do like different forms of transformation. Like say, for example, I might want to replace all the dollar here. So replace all the dollar here with blanks so that I can have just numbers. So you can see that they're just numbers now, and then I can now say I want to deal with them like currency. So you can see that now when you load this data for this gross sales column, it will now treat them like actual like currency values as against what was there before, where it was just it was just a text. So these are some of the things that you can do within Excel, and you can achieve the same thing in Power BI. So this is something that you may just want to study a bit more on your own when you're doing your own like your self-study. You want to like upskill yourself. So when you're done with all of this, you then will close and load. So you just be loading the data. But for this case, let me I'm not planning to do any of that. So I'll discard that. So when you load that, it basically comes into your interface looking somewhat like this, but much more organized. It comes as an organized table, and then from it you can now begin to do analysis. In Power BI, when you complete the transformation steps, you will now see your data in this. It's called the data view of your Power BI. Then you see the data that you've imported that is cleaned up. You see it in Power BI. So for this particular project, we worked with five data sets of five tables, and basically with different relationships that exist between these tables, we were able to do different analysis. So for example, we brought in data on geopolitical zones, we brought in name of awardees broken down by states, universities, and things like that. And all of this process is not a direct just pick the process. I showed you an earlier phase where you might have to automate and bring in multiple tables. Like for this one that has 9,000, almost 10,000 rules. So these are some of the things that you'll be doing as an analyst. You'll be importing data, cleaning data, and then when you now clean the data, then you now want to do something that's called modeling your data. So by modeling your data, you are trying to establish clean relationships between your different tables. So all of these things you're seeing here are these same five tables I earlier discussed, but we're now trying to establish relationships between them. And what are relationships? So let me just touch one particular relationship. So we can see this table, MSc and PhD interviewees, and then these other tables on geopolitical zones. This relationship is saying that they are related based on a field called states. So it means that in this first table for MSc and PhD, we have data for different people that also categorizes them by states. But in this other dimension table here for geopolitical zones, we also have state information. So because they both have state information, a relationship can be created. So sometimes Power BI most times will automatically detect some relationships, but for you to do maybe much more complex analysis, you might need to define some relationships that Power BI will not typically identify automatically on its own. So another thing to note is that there are different kinds of relationships. Like in this case, you see one on this place, one, and then you see this asterisk. This asterisk basically means many. And in the context of data analysis and database management, it just basically means that the relationship that exists within these two tables is a one-to-many relationship. So we would have one instance of states in this geopolitical zone table, and then we have multiple instances of states in this MSc and PhD interviewees. Let me just show you that. For example, in geopolitical zones, let's look at that table. You can see that we have just one instance. Benue is once, Kogi is once, Kwara is once, while in the other one, MSc and PhD interviewees, you will have repetition of that state, FCT, Abuja, Gombe, like it's just repeating themselves like that. So because of that, we're able to establish that one-to-many relationship. Sometimes you might see one-to-one relationship, but when you see a one-to-one relationship, most times it just means that you can just combine those tables and just make them one table, because you have just one instance here and one instance in another place. But there are some special cases that you would need to just maintain that one-to-one relationship instead of combining those tables. So I don't get too technical. I feel like this is something that we can just develop ourselves at our own pace back at home. So when you've created all these relationships and co, basically what you've done is that you've modeled the data that you brought in. And then with this modeled data this data model that you've built, you can now proceed to visualize what you've done. So for example, I'll just talk through some of this. So on this page, based on the data that we had collected and relationships that we had established in the model, we are now able to talk about how people were distributed across these two scholarship types, or how they were distributed amongst the different countries that they applied to. Another visualization here, just ranking in terms of geopolitical zones where the applicants came from. So it's breaking it down basically into the different geopolitical zones that we have. And then we have another one that is just showing the distribution between genders, male and female. We have about 69% male here, 31%. These are some of the some things that you might not have been able to just look at all of the table, the 9,000 rows, and be able to just pull out of the data. But when you're able to model your data correctly, you can now start bringing out some of these insights. And then sometimes you just make use of these cards that are in Power BI here. So cards are here. You just to give like straightforward information. So we just have 403 awardees from 282 local government areas, 36 states, including the FCT, making it 37 across 6 geopolitical zones. You can write comments on what your data is telling you. You can do a lot of things within Power BI. But I just wanted us to appreciate how we worked from where we got the data, how we applied a bit of automation using Python, brought the data into Excel or Power BI, because one interesting thing to note is that you can do all of this analysis in Microsoft Excel as well, because you have access to charts, graphs, you have access to the same Power Query. This idea of data modeling can also be done in Excel using a tool called Power Pivot. That's the Excel version of this whole data model that we've done here. And then when we do all of that, we can now build interesting visualizations that give us insights into the data. So that will be that about the case study break. So we see that we work from data collection to visualization, which is the typical workflow for maybe any data analysis venture or projects. So next, let me just talk on some of these things that I would have mentioned them while I was talking about the case study. First, we'll talk about the hard technical skills. So these are just basically the core skills that you will need as an analyst to do work. So you need to extract and transform data. You probably need to use SQL. I didn't give an instance of SQL in the case study because I wasn't working with a database. If you're working with a database, that initial step will be pulling stuff out from the website from multiple pages. Will now be you using SQL query language, SQL, you write queries to pull out data from the database. Then you are modeling your data using in Power BI, using Power BI, or you're using Power Pivot in Excel. Then you can also just analyze your data, visualize your data, look at graphs, charts, compare variables, evaluate relationships between different data sets. And there are just so many things that you can do with your visualization tools after you have collected, cleaned, and modeled your data. And then something that I noted here at the bottom is that I just wanted to give us an idea of where some of the places where we can learn some of these hard skills for data analysts. So here I've mentioned Coursera, Udemy. Udemy is a very good place for where you can learn things like SQL, general data analysis. Google Analytics has a mini, what would I call it? Is it certification that they have for data analysts. They're also teaching ed tech services like Data Camp and Data Quest that give very, very solid teaching resources for data analysis, whether you want to focus on data analysis, data science, data engineering, automation, all of those things. These people provide some of those services. So let me just switch back to so that it's clear. So next, soft skills. It is very important that in addition to those hard skills that you have, you also have soft skills. If you are not able to communicate some of the insights that you have discovered, then your analysis sort of becomes useless. So it's very important that you know how to speak to people, you know how to gather information, you know how to gather data from your stakeholders, you know how to present insights, present challenges, business solutions to the users of your data. It's always good to know how to also organize the insights that you have gotten. So you might also need presentation skills. You need to know how to use maybe PowerPoint to organize some of the things that you want management or your other team members to use. You also need to know how to relate to people, stakeholder management. Not everyone is usually, you're an analyst, but not everyone is just waiting for you to come and get data from them. So you need to know how to relate to people, to effectively and efficiently gather data from them to make your work much more easier. So I rounded off here saying that soft skills augment hard skills. If you have just hard skills, you might be able to do the work, but you will face a lot of challenges at every step of your analysis journey. But when you're able to integrate your hard skills with your soft skills, then your skill set is much more complete, and then you have a much smoother workflow and a much smoother analysis. So in conclusion, I just wanted to highlight some of the key takeaways that I want us to take from this presentation, and is that one, statistics plays a very important role in data analysis. You can't really separate those two concepts. Next, correlation is not causation. Take that away. The context in which you're looking at your data is very important. Then the process of data collection and cleaning takes a very considerable part of your entire analysis workflow. So a lot of people like to see the interesting, beautiful visuals, but a lot of work goes into, I'll say up to 70% of your work will go into 70 to even 90% of your work, and the energy will go into collecting and cleaning the data before you now start to visualize insights from your set data. And the last thing is that while hard skills are very important, it is very important or very I can't put it. It's very key that you integrate them with soft skills so that you'll be successful. All right, thank you very much, guys. I would just stand by for your maybe questions and suggestions. Thank you. Hello?
Thank you very much for this wonderful presentation, sir. We are very, very grateful to have you. It is truly a privilege to have someone of your experience come and take us all these things. These are things we thought we knew, but after your very broad teaching, we can see that there's still a lot to learn. Thank you very much for exposing us to all this. We are very, very grateful. At this point, we'd love to take questions. I can see there are some questions on the chat. Yeah, okay. Okay, so I'm just going to begin with the first question from Temp M. They said, I saw on the PTDF site a download button. Why didn't you just use that? I'm not sure I understand this, but do you understand this question, sir?
Okay.
Can you hear me, sir?
I think I get the question. So
Okay.
the answer to that question is not every site would have a download button. You might want to scrape for data from Twitter or Facebook. Facebook doesn't have a download button for all comments from people that are looking to buy air freshener this week. So the purpose of that Python automation or web scraping procedure was to let you know how you can pull out data from sites that do not necessarily have, in quotes, like you said, download page. Not all pages will have download button. So that was just for what's it called? Um, was just for illustrative or learning purposes. Yes.
Okay. Thank you very much, sir. I believe your question has been answered, Temp M. I asked a question. I said, which software did you use for Power BI?
Okay, so it's Power BI. So Power BI is a software on its own, and it's available for download for free. So if you want to learn it, you can just search it up on Google. Power BI. BI just means business intelligence. So it's a software on its own that now incorporates different modules like the Power Query part of it, and with it you can do a lot of analysis and visualization. So Power BI is a software on its own. You
All
understand
right.
that?
Yeah, I understand this, sir. Before I go further, if you have any question, please kindly signify. You can raise your hand, or you can just type the message and send it there. So if you have any question, you can raise your hand, or you can send the message and we'll read it out for you. I also have a question, like a follow-up question to the one I just asked now. You mentioned SQL.
Yes.
Is there a software for SQL as well?
So SQL is a language that you use to query databases. So there are different database like management softwares. Within this software, how you query the database that's hosted maybe within the is using SQL. So for example, there's Postgre, there is MS Access, there is MySQL. So SQL is the language that you use within those database management systems to pull out data from those databases. I hope that was
Oh, all right. So it's just a language,
yes, it's a
just like
language.
Python and the
Yes,
rest. Oh,
yes,
all
but
right.
it's for databases.
All right. So that's just a language for databases. Thank you very much for this, sir. Fortune asked the question. He said, "Is Google Analytics accessible for free? Is Google Analytics accessible for
Mm,
free?"
so in most instances it's not, but there are ways around that. So there are some bodies that sponsor some of these analytics programs. For example, I know that in Coursera, you can apply for each of those courses in the Google Analytics certification. You can apply for each of them as a standalone. You can apply for financial aid. You get financial aid, and then you study the course, and then you can apply for financial aid for the next course like that. So there are ways around. If finance is a limitation, then there are always ways around learning. So there are many other data analysis courses on Coursera that you can just apply for financial aid as an African, and then you get it and you can study and gather knowledge.
Okay, all right. So I believe this answers your question, Fortune. Uh, so far there's no other question to take. So I believe at this we can draw the curtain at this note. Thank you very much, everyone, for taking out time to be part of this. We are very privileged. Without you, we wouldn't be able to have this seminar. You are equally important. And to the facilitator that has taken his time to prepare this presentation and to deliver this presentation with such finesse, we are very, very grateful. We look to hear from you another time. Thank you very much, sir. Thank you very much, everybody. Uh, this brings us to the end of Data Analysis 102. Thank you very much, guys. Bye.